Hey, I'm Jason Miller. I'm an agronomist with NRCS. I've been with the agency for 23.5 years. And actually, when I was going to college, Ron was my advisor. So that's been a while.
Thanks a lot.
I was back in the late 80s, and I actually started with NRCS when I was a couple years left in college. So that has helped build the years there. But I was going to talk to you about setting up soil management zones and some of the soil properties that would contribute or that you should evaluate or consider when looking at developing some soil management zones. And if we look at variable rate application itself, it's actually just one component of precision agriculture. If you ask a guy, does he do precision agriculture, he'll say, sure, yeah, I got auto steer. Well, he's right. That's one other component of precision ag. Several of them have yield monitors in them and so forth. So there's various forms of precision ag, and I'm just going to talk about one component of it, and the variable rate side. And if we look at is it truly precision agriculture when we're trying to manage nutrients and plants spatially? I mean, it's the technology that allows us to do it, but it's really a management philosophy is what we're trying to get at. And if you look across the state, NRCS has mapped over 500 different soil types. So looking at across the state, yeah, there's a lot of variability out there. But looking at just on a field scale basis, you know, how much variability is on any given field. I've been in several fields where there's 70-80% variability. I mean, you got knobs, and then 1 second you're down on the draw, another second you're up on the knob. So some fields have a lot of variability, and variable rate fertilizing and seeding definitely pays. So it's kind of, the producer really needs to decide on, is that field variable enough to pay for the services of setting up the zones and the expense of making sure his equipment will variable rate. And if you look at South Dakota, generally our crop yields depend on soil moisture and soil nutrients. Those are really the two key factors. I don't think anyone here would argue that. Now, what properties influence soil moisture and soil nutrients? Mainly soil texture, organic matter, and salts. And if you look at the soil texture, the sand, the percent sand, silts, and clay, that's definitely an inherent soil property. That's really something you can't change. Soil organic matter levels, we know we can change, we can decrease in a hurry, but to build them up, it takes a long time. You always read in farm magazines that producers, I raised up the soil or the organic matter level 1% in 5 years or whatever. It can't be done. It cannot be that fast. It takes a long time to rebuild those organic matter levels that tillage basically is destroyed over the years. And then salt levels. Is that an inherent soil property or not? To a certain degree, majority, probably yes. But our management on some cropland fields, like converting it from grass where we're not using water constantly or throughout the entire growing season, we've changed those. We've probably increased some of the salts in some areas, and actually last year was probably one of the better years for us as far as trying to deplete that soil profile, moisture level in that profile. So when we do get a rain, it will actually leach some of those salts back deeper where they originally were before 2008, 9, 10, and those wet years when they occurred, and in the late 1990s. If we look at soil moisture itself, how does texture impact soil or plant available water? If you look at a silt loam or a silty clay loam, high organic matter levels and no salts, you're looking at 2.5 inches of plant available water. If you compare that to a loamy sand with low organic matter levels and no salts, 3/4 of an inch of plant available water per foot of soil. So there's a huge difference in soil textures, organic matter levels, etc., that can play a role in trying to manage that soil profile from a moisture standpoint. How do salts impact soil moisture levels? The more salts you have in the soil, basically the lower plant available water you have, just because that plant root hair can't extract that water from the soil with that salt being there. And I'll have 5 different cores on the back of my pickup over there that we'll take a look at here when we're done. And I have one particular one that has has some salts that's starting to move up in the soil profile. When we look at soil nutrients, organic matter plays a huge role in the availability of nutrients such as nitrogen, phosphorus, sulfur, and zinc. And if you look on page 5 of that handout, there's a little chart in there, a little graph in there that shows different landscape positions that were sampled. And that upland position wouldn't be on a knob. It would probably be a back slope of something, approaching somewhat of a foot slope type area. But if you look at that, the pH level, 6.4 organic matter, 3.9 EC is good, only at 0.1. The nitrogen, this would be a combination of 0 to 6 and 6 to 24. There's 28 pounds there. Phosphorus, Olsen phosphorus test, 12 parts per million. And you jump down to the next one there, the eroded knob. Look at your pH level. Jumped up to 8.1. What do you expect to happen to some of the nutrients with 8.1? It's going to start tying up phosphorus. You notice your phosphorus test is way down to 5. You don't have as much organic matter there because it's been lost either to erosion or to tillage erosion. That's down to 11 pounds of nitrogen. Even your potassium and your sulfur levels are really low in that knob situation or eroded area. Now you compare that to a little bit of a swale approaching on a wetland type status there. You would expect your phosphorus levels to rise because where did that deposition occur? It occurred in those swales from the upland portions and brought down organic matter levels. So those are inherently a little bit higher due to that gain in organic matter. And your nitrogen rates are a little bit higher. It's going to stay wetter longer. You're going to get just a little bit more mineralization in those areas. And you compare that to a saline area, an area that was affected by salts. You look at your EC reading there of 3.3. That's a fairly high reading. I can't tell you if that's a 0 to 6 or a 6 to 24 or if that's an average or what that is, but at 3.3, especially if it was in the surface, it's very high. Or at least in my mind, it's very high. It's going to impact definitely soybean growth and corn growth. But look at the nitrogen phosphorus, 113 and 26 pounds or 26 parts per million phosphorus. That tells me that producer overapplied in those areas and those nutrients weren't utilized the previous years. So he was, basically probably flat rating for 130 or 150 bushel corn. Just weren't being utilized. Those would be areas that we can definitely cut back on. Okay, so from there, these next slides were developed from those two sources that I have listed there. But you have to have a computer program that's going to be tied to a GPS unit when you go out to the field. And there's a number of different companies, producers who are developing soil management zones using different software programs. ArcMap, FarmWorks, Ag Data Viewer, Ag Leader, etc. There's a whole host of them, and this by no means is a complete inclusion because I know there's a lot of companies out there that have their own. Winfield has something, I know that's a proprietary thing. Wheat Growers has something else that's a proprietary thing. So there's a number of programs out there, but these are publicly available for people to use, and I would say probably 90% of the consultants, 95% of the actual private consultants out there use that Ag Data Viewer made by GK Technology out of Minnesota. Producers will create their own soil management zones based on knowledge of the field, based on yield maps, those sorts of things, and they'll use something like FarmWorks or Ag Leader SMS or John Deere Apex type software, where they can do that themselves, and I know a few guys doing that. Now, what information is used or layered together to form soil management zones? And I have a list there of topography, satellite imagery, aerial imagery, soil electrical conductivity, yield maps, producer knowledge, and digital soil maps, NRCS digital soil maps, and we'll talk about each of these here. Topography, what do I mean by that? Elevation, topography of the ground. It's very easy for someone to see a hill or a swale out there and pick up or recognize those areas. How do you draw them in? Well, you can use elevation data or topography information, and there's a couple different sources listed there. LiDAR information is available. For the most part in South Dakota, it is not available. There's only a few counties way on the eastern side where it's available that you would have to download through USGS, but it's very accurate stuff. I mean, we're talking within 6 inches accuracy, very good stuff. IFSAR is elevation data that NRCS uses, and unfortunately at this time it's not publicly available. That is not as accurate as LiDAR. And both of those file formats, if you get something for a county, the LiDAR stuff takes up a lot of space. It's a very large file. You can also get off of just the producer's equipment, you know, when he's out there planting or spraying, that's actually recording elevation data as he's going across that field. So you could get that card from him. And if you have that software for that controller that he's using, download that and get that elevation data from that. Is also an option. Some of these companies that are using Veris carts actually have RTK equipment with them, so they're actually recording very detailed elevation data as they're going across that field already in 40 to 60 foot swaths. So topography is definitely one thing that can be used now. Is every lower area, you know, as you're coming off that ridge and you're getting down into that lower area, is that always a good high producing area? Not always. Now, I'm not talking about a wetland, I'm just talking about a general foot slope position. A lot of soils, yes, and a lot of other soils, no. I mean, you can run into clay pan spots, you can run into salts that are under the soil surface there, and we'll talk a little bit more about that in a minute. Another form of or a tool that you could use is satellite imagery, and I listed a couple websites there. Most free satellite imagery is 30-meter resolution, which means it's actually fairly blurry when you zoom in and want to be able to see a field in detailed situation. As far as creating zones, I know a number of companies were using the 30-meter stuff, and they were getting by. I mean, it was okay. It's just something where it's not quite 100% on. It wasn't picking up smaller areas, salt rings around some, you know, fairly large salt rings around sloughs. It wasn't picking those areas up, etc. But there is other satellite imagery sources out there. You can get some at 18-inch resolution, but it's going to cost you a lot of money. Rapid Eye makes one one is available for 5-meter resolution. If I remember right, I priced that at about $1.50, $1.75 an acre, if I remember right, something like that. But you have to buy certain segments of the county or that particular area. There's so many minimum square kilometers that you have to purchase. So you may want to try to, you know, lump fields together or whatever there to make sure you try to get the biggest bang for your buck. But when you're looking at the satellite imagery, you really need to be aware of, okay, it's taking a picture every 16 days approximately. And you need to know for that particular year what crop was growing out there, so you can be looking for that time period when you would want that satellite imagery. Because if the wheat was harvested, you're obviously not going to want any August, September, October type satellite imagery. So for corn, you're looking at late July, and most years small grains late May to early June, depending if it's winter wheat, spring wheat, etc., etc. Soybeans early to mid-August would be a time period that you could look at. Those sorts of things, I guess. Now, that UMAC site has satellite imagery that from 2011 until about 1999. The satellite quit operating last year, so unfortunately there was no free satellite imagery out there that was really worth a dang. Free satellite, there's other satellites that were okay. They put a new one up in February and they're already sending back images, but for that one you can't go to UMAC, you have to go to USGS to get that information. And USGS, it's a little bit more cumbersome to try to extract that information off there. You're going to be downloading a fairly significant map versus just like UMAC, you could actually zoom in the field and just export that particular small piece out. So you were able to get really good imagery or fairly decent imagery for a small area, so your file sizes weren't so large. And that's probably one of the biggest problems with setting up zones is you just have volumes and volumes of information. And you cannot buy a hard drive that's too big when you're setting up zones, because you will fill it up, I'll guarantee you that. Now the next one, Nghiep Imagery. It's a free imagery available from USDA. There's a website you go on there to download a particular county. And for South Dakota, the years that are available are 03 through 06. And for 03, it actually quits about the Miller area. And it's only that area that has 03 available. There's a couple West River counties, very few, but for the most part, it's mainly East River that 03 is available. But otherwise, the entire state has 04, 05, 06, 08, 2010, and 2012. Resolution is very good, 1 to 3 meters. 2008 on was 1 meter resolution stuff. Very detailed, and that can be a downfall in some situations. It can be too detailed, depending on that producer's equipment, etc. Another downfall would be if there's only 1 image per year. So it's only taking it, for the most part, these photos were taken in mid-July time frame. 2008 was the only year that was taken earlier than that. So if you have a guy that has rotations with wheat in it, most of the time you're going to get a picture that wheat was already harvested, and that imagery doesn't do you any good.
Looks like our truck's coming, Jason.
Is it already?
Trying to wrap this up or what?
Heck, it's only 3:30. Soil sensors is another one, Veriscart. Several different things there that's measuring, really looking at the clay content, soil moisture, high organic matter, etc. I don't have a lot of experience with it, but you can see on the next page here, it created a map there, and it does show you something. And they happen to overlay a soil survey map over the top of it, and you can see some areas were close and some areas were not. But again, that thing measures organic matter, moisture, nutrients, and salt. So without being out in the field, what is that really telling you? Yield maps is another one. Let's go down to digital soil maps here. That's on page 11. NRCS digital soil maps really, for the most part, can give you a guide of what's out there. I would not use it as your sole layer for developing zones. It's just too broad, and the reason for that is the technology that we had back in the day in the 70s when most of these were created, we just couldn't get that close and draw those lines in there. And I have a few slides there that show you how far out compared to what it should be when you're setting up zones. What time we have to leave?
I don't know.
Oh, they were just done?
Yeah, they're done. Should I come back? I think that would.
It's entirely up to you. I can probably wrap up in about 7 minutes.
I'll wait 7 minutes or you want to go in? Nice and cool up here.
Okay. Page 13 there at the bottom is just the example zone map I created down there, so that will be on my father-in-law's ground south of Huron. If you're familiar with that area whatsoever, there's a lot of salts in that country, and that's what those zones 10 and 21 are. Zone 10s are really high in salt and they're white to the surface. 21s are going to be subsurface salts. Zone 1s are going to be your best. 3s are going to be your moderately eroded knobs. 4, more eroded knobs, and 5, you're gonna have no topsoil left whatsoever. 19s are sands, etc. There. Now, most zone maps are only going to have 3 to 5 zones for the most part. This is just ground that has just every flipping soil underneath the sun that in there. So I drew them out, and this will be the second year of corn on there. So they seem to be unbelievably, they actually lined up with the yield map back 2 years ago. So we'll see what happens this year. I've already mentioned the zone map development there as far as 3 to 5 zones. Now, bottom 14, you look at this aerial imagery and you see signs out there. You see different things going on. You can't create these zone maps from sitting behind the desk in the office in the wintertime. I've tried that. And until you go out in the field, you're going to have, you don't have any idea what this imagery is telling you. Was it a weed patch that year? Is it a salt area? Is it a knob? Is it a, you know, all sorts of things can be happening, and just by looking at that imagery without being out in the field, it just is not a good way to create zone maps. So in summary on this, number 2 there needs to make sense to the producer. You should be able to lay that zone map in front of him and tell him that this is the good area of the field, these are knobs, you have a sandy spot over here, etc. He should be able, yep, you know, as long as he's been across that field a number of times, he should know that. It should make sense to him. Uniform crop production is not the goal. We shouldn't be using variable rate technology to create every acre out there producing 180 bushel corn. Those inherent soil properties out there just cannot do it. I get producers telling me, you know, why can't I grow 180 bushel corn out here? What's limiting it? What nutrient do I need to be putting out here to do that? It just can't be done. So variable rate technology is not to create uniform crop yields across the entire field. Those areas that are poor producing areas, you need to be cutting back your corn plant population, you need to be reducing your nutrient inputs, etc. Economic potential must be present. I already talked or hinted on that before, that there's no variability out there, that producer's not getting anything. You're not really going to help him whatsoever other than take more of his money. So that field needs to have some variability in it in order for it to justify paying off for variable rate. With that, let's go over to the pickup and take a quick look at some soil cores I pulled on Monday. Okay, looking at the soil cores, which ones would you say is the highest producing or the best producing zone or core? And normally,
This one or that one? Probably this one.
well, no, you're wrong. But yes, looking at it, just quick look at it, it's the darkest, which would generate, it would make you think you have the highest organic matter. But actually, this one over here is, most people that set up zones or soil sample are only looking at the top 2 feet. So a lot of times you don't see. And I took these with NRCS probe down to about 4.5 feet. So you're probably stopping about right there and looking at it. Now, does anyone know what this bottle of this stuff is here? Yeah, hydrochloric acid. Just it's a very low rate hydrochloric acid. And why do I have this bottle? It's really to look at when the calcium carbonates, where they start fizzing from the bottom, or start fizzing from the top, and that's going to tell you your topsoil thickness. Look at these; they're starting to fizz there, fizz in there, a little fizz there, so it's about right there. And these soil cores are dry, so it's a lot easier to see that versus when they have some moisture in them. You just can't see that a lot of times. I always carry a bottle of this around because a lot of the zones are set up based on topsoil thickness. I mean, you look at the first 5 zones of that example there, and it's all based on topsoil thickness. You're actually getting some calcium carbonates, maybe some calcium sulfates coming in down here, a lot lower in the profile, but you have a good 3 feet of a good dark topsoil. This one is going to be more typical of an area that's probably going to be predominantly of the field, maybe just a little bit slight less of a topsoil thing, but pretty dang close. This one here is an eroded knob. And if you take this bottle, pretty hot, you see there's not a lot of topsoil left there. So that's going to be an eroded knob. That's where your P levels are going to be fairly low there because they're being tied up from those calcium. This next one over here, this next one over here is actually a clay pan soil. And the clay pan actually begins right here, which is about 10-12 inches below the soil surface. And it's a lot easier to see this. Now, has anyone ever sampled the clay pan soil by hand? Very quickly when you hit that clay pan layer. If you got a 4-foot probe, it stops you immediately. So this is a layer right here that's high in sodium. and it actually disperses that layer there, so you actually get a columnar soil structure, and it basically surface seals it from water penetrating, or very slowly allows it to penetrate below that. A lot of times you'll hit that, and then right underneath you'll have dry soil for an extended period of time. Now if you're actually sampling those clay pans when it's really super wet, it'll be just a real slick area that shows up about that wide. That's another telltale sign, but most of the time when it's dry, you pull that out, you can see exactly where that clay pan layer is. Now, with the clay pan down only a foot below the surface, that's going to tremendously impact crop yield, even wheat. If that clay pan layer happened to be down another foot and a half, not so much. It's actually going to create somewhat of a sub-irrigated system if you happen to get rain, and it won't bother the corn plant as long as you keep getting some rain. Now this one is actually, at one time, probably 5 to 10 years ago, was this soil over here. You notice the salts started moving up. This is getting closer to a wetland site, but the salts are moving up. Look at that, you can see the salts in there. The salts are moving up, and it's going to start limiting some crop production. Now again, like I said before, 2012, even though it was so dry, it helped. It really helped deplete our soil moisture levels. So when we did get a rain, it would help leach these salts, because these salts are very mobile in water. And once we completely discharge that soil and then get some decent rain on it, we can actually leach those soils back down, or leach those salts back down. But this is actually going to fizz too. And if you look at that sheet in there for those example soil test values, you look at that saline area, and it showed it was, what was it, 480? That's maxed out. And a lot of times in any of these saline areas, if you see 120 for your 0 to 6 for your sulfur test, and 320 for your, or 360 for your 6 to 24, you have some salts going on. Most of the time it's going to be calcium sulfate or sodium sulfate or magnesium sulfate. That's going to be the salts that are moving around. So, are there any questions whatsoever?